Hello there! This video will show you how to compute z-scores in Microsoft Excel to compare different values within different distributions and within a single distribution. This video is primarily going to look at using z-scores to figure out if there's any extreme values in your data set, or in other words, any value or score that has a z-score less than or equal to -2 or greater than or equal to +2. All right, so we're looking at some data, looking at the different types of bread and the different days of the week where we collected data, looking at how many loaves of each bread was sold at Great Harvest Bread Company. So the first thing that we're going to want to do is to figure out the z-scores, down here is where I'm going to put them, for each bread type. Now, real quick, I notice when I scroll down, I can't see the bread types. I don't like it, so go to View, Freeze Panes, Freeze Top Row. Now when I scroll down, I can still see the different bread types. Now I want to point out that technically we are going to be creating z-scores for sample means, but we aren't really looking at all of these values at the same time and then figuring out different z-scores associated with different means from different sample sizes here. What we're going to do is basically create a mean value for each bread type across all these values and treat those means as single scores or X values. Basically, we're just going to use the mean as a single score that represents the overall sales of each type of bread. Then what we're going to do is figure out the mean and standard deviation of all these means, so the mean of the means and the standard deviation of the means, and then figure out the z-scores. All right, so let's check this out. We're going to put mean equals, and you've done this before in separate lessons here. So equals, we're going to highlight all of the harvest white values. An easy way to do it, click the bottom value, scroll up to the top, hold down shift, click the top value. Or, of course, you can just kind of click and drag all the way down. Hit enter. Whoa, what just happened? Let's see. Equals, try again. Average, double click the word average, that's important. Then highlight, shift to highlight all of them. All right, that's more like it. So now we're going to click, get the little plus sign at the bottom right, drag over to copy that formula across. So now we have the mean or the average for each different bread type. And just to check the formula, you can see if we look up here, this is the average of now the F column, F2 through 22. So that formula was copied over. If you're having issues copying the formula over, you could always just click and drag, starting with the first formula you did, go to the Home tab, and fill right. Okay, so these are what we're going to treat as X scores. These are the scores for each different type of bread. Now, before we can figure out what our z-scores are, we have to calculate the mean of these values and the standard deviation of these values. So let's go ahead and do that right here. So the mean of means, we can say, equals, I'm going to just double click right here between A and B, where that double-sided arrow is, so that the mean of means is displayed. And I'm just going to write SD equals for standard deviation. So to figure out the mean of all these means, we're going to do equals, start typing the word average, wait for the word average to pop up and double click it, then highlight all of these means and hit enter. To figure out the standard deviation, equals STD, and we're doing sample standard deviation because this is a sample of data. It's not all the bread ever sold. Double click that, standard deviation for the sample. Highlight those mean scores again that we're really just treating as X values for our purposes, and hit enter. So now we know that the mean of mean bread sales for all the different bread types is about 364.485, or about 364 loaves if we're going to look at whole numbers. And the standard deviation is 191. So if we think about this, we can say like the range of most bread sales. Remember, most bread sales are going to be within one standard deviation of the mean. So we could put from the low end equals this mean of means minus the standard deviation, 2 equals this mean of means plus this standard deviation. So we know that any type of bread that has a mean number of loaves sold between 173 and 556-ish is really just a kind of a common value. It's not really unlikely to happen. There's a huge variation here across the different types of bread for sure. Remember, this would correspond to a z-score of -1, the mean minus 1 standard deviation, and this would correspond to a z-score of +1, the mean plus a standard deviation. Just to confirm that, I'm going to show you how to use the z-score formula here before we do it for the actual scores. So z equals, type in stan, get standardize, double click it, highlight this x value, the actual value itself, comma, the mean value, comma, the standard deviation, and check it out, z-score of -1. Let's do it for the other one, equals. Standardize. So just start typing in standardize till it pops up. Double click. This x value, comma, this overall mean value, comma, and the standard deviation. Enter. And there, I just proved my point. So now we're ready to compute the z-score for all the different bread types. So we're going to go here, equals st, double click standardize, click on the actual x value, comma, click on the mean. Be careful here. Once you click on that, hit F4 or put a $ in front of the letter and the number. This locks it in so that when we copy that formula across, it's going to be reading this mean for every single one, and it's not going to look for a mean value down here for each subsequent column. We're going to do the same thing with the standard deviation because for all of these, we want to use the same mean and standard deviation for the formula. So when we click the standard deviation, hit F4 or manually type in a $ before and after, close it in a parenthesis and hit enter. Now we can click this, drag across with the little plus sign at the bottom right, or if that's not working for you, click and drag, starting with the first one, fill right, and we have all of our z-scores for all the different types of bread. So we can see here, and this is because we're looking at the same distribution, the conclusions we make with the mean and z are going to be really similar. The highest, the bread with the most number of loaves sold is Harvest White, and guess what? It has the largest z-score. The bread that has the fewest number of loaves sold would have been the sourdough, and check it out. It has the lowest z-score. Notice that the value that is above the mean of 364, all those values, or sorry, the values that are below, and I'll highlight those, the mean of 364 have negative z-scores, right? And the values that are above the mean of 364 have positive z-scores. And if you look at, for instance, sourdough, we can see that sourdough is, the number of loaves sold is 1.235166 standard deviations below negative the mean. It's just helping you remember how to interpret z-scores. So maybe a practical application of this would be, let's say that the store at the Great Harvest Bread Company, the store manager is considering removing any extremely unpopular types of bread from production. So maybe any bread type with a z-score at or below -2. And they also want to raise the price for extremely popular types of bread. So any bread type with a z-score of 2+. Well, based on these z-scores, none of the bread types have an extremely low or high level of demand that actually warrants any changes, so they can just keep functioning as normal. If they wanted to change their standards, maybe get rid of the least popular type of bread, they could do that here, but they wouldn't have necessarily needed the z-scores to do that. Okay, here we go. Moving on to a situation where we are looking at different distributions, and we're going to try to compare performance across different employees while controlling for the location that they actually work at. So let's say that the Las Vegas and Henderson Great Harvest Bread Company franchise owner wants to increase the sales of Savannah bars. So that's the data we're looking at, is their sales of Savannah bars. So to motivate employees to push the Savannah bars, the franchise owners promise a $200 bonus to the 2 employees with the most impressive mean number of Savannah bar sales in the next month, and promises to suspend the 2 employees with the least impressive number of Savannah bar sales in the next month. Now, to make sure that this evaluation is fair and not biased by the employee working at a busier or a less busy location, the franchise owners are going to look at each employee's Z-score based on their mean sales compared to the overall mean and standard deviation of sales within their store location. So the employees with the 2 highest Z-scores will be given the bonus, and the employees with the 2 lowest Z-scores are going to be suspended. So let's take a look at the Z-scores for each employee within their actual location. So again, looking at the data, Savannah bar sales, we're going to give a bonus to the 2 cashiers who have the highest sales within their location across the board, and suspend the 2 cashiers who have the least impressive number of sales amongst the rest of the people at their location. So you'll see Sally, Mark, Lonnie, Kate, and Jerry all work at the Mark Street location, and you'll see all of their scores here. You'll also notice that I already did the average or mean and standard deviation for these by just doing the average formula with these scores and the standard deviation formula with these scores. And you'll see that for all of these. So we're going to figure out what is Sally, Mark, Lonnie, Kate, and Jerry's Z-score based on how many Savannah bars they sold over the past month per week on average compared to the actual average of the whole store. So here we go. So equals, look for standardize, double click it, highlight their actual score. You can't see it, but if you go far enough to the left, you'll see the little plus sign. You can just click it. You see it's highlighted. If it doesn't let you click it, you could always manually type in C6, then comma, the mean for the store. Remember F for it, so it locks it in, or $ in front of the letter and number, because we're going to use that mean for all these cashiers. It's not going to change. Comma, standard deviation, click that. F for it to lock it in. Hit enter. Then click on the Z-score. Go down to the bottom right where you see the plus sign, or just highlight down and fill down. Oh, we don't want this because there's no score there. Get rid of that. Now you have the Z-scores for all the cashiers. Now let's do that for each cashier at each location. So for the Horizon Ridge location, we're going to look at this mean and standard deviation to evaluate these cashiers. Because maybe the Tropicana location is just busier, and that's why some of these scores are higher, right? So to control for that and not just automatically give the bonus to the person at the busier stores that has an advantage, we're going to compare their actual sales to the sales within their location. And that's what these Z-scores are going to help us do. So equals ST, double click standardize, highlight the score for Curtis, comma, the overall mean for Curtis's location, hit F4 or use the $ to lock it in, comma, the standard deviation for this location, F4 to lock it in, or $, hit enter. Now we can click and drag this down with the plus sign to copy the formula down for everybody at Horizon Ridge. We're going to do this 2 more times. You're going to be a pro by the time we're done here. ST, double click standardize, highlight Maya's value, comma, the mean, lock it in with F4 or $, comma, the standard deviation, lock it in with F4 or $, hit enter. Click, go down here, little plus sign, or do the click and drag, fill down method. One more. Equals ST, there's our standardize, the X value for Caleb, so how many Savannah bars per week on average they sold over the past month, comma, the mean for Decatur location, F4 to lock it in, or $, comma, the standard deviation for Decatur, F4 to lock it in, or use $, hit enter, and now we're ready to copy that formula down. So remember, they wanted to give a $200 bonus to the person that had the 2 highest Z-scores, or the most impressive number of Savannah bar sales within their location. and then a suspension to the two of the most least impressive within their location. So if we look here, we'll be able to see, kind of based on the z-scores, who those people are. So let's see, what is our lowest z-score? It looks like our lowest z-score is for Mila here. Let's make that red. Sorry, Mila. It's not looking good for you. And then our second lowest z-score, I believe, belongs to Miriam here. Sorry, Miriam. So it looks like they're getting suspended, right? Oh, boo. Ironically, they both have a 15, which is kind of interesting. So now let's look at the best performers. So it looks like the highest z-score belongs to Lysine here. Let's make that green. Maybe bold it because that's a little bit hard to see. And then the next highest z-score looks like it belongs to Curtis at the Horizon Ridge location. Make it bold. So check it out. Z-scores allow you to compare how extreme or impressive or not impressive scores are from completely different distributions. It wouldn't be fair to just compare these scores because they're coming from different distributions. We don't really know how impressive those sales are until we compare them to the overall sales at their location and the typical difference in sales at their location. So you just use z-scores to make decisions based on comparing different scores from different distributions. So congratulations to Curtis and Lysine. Sorry, Miriam and Mila.